All right. It is warm in here. It's not just me. I'm always warmer than anybody else. So 20 is, ooh, 11. All right. What does composition of functions mean? What does that mean?
Function inside of a function.
Say it one more time.
Function inside of a function.
Function inside of another function. I love it. And I mean, let me give you an example of forward one, because this is a backwards one. So what the hell do I mean? Here's a forward one. I give you f of x is square root of x minus 1, and g of x is x squared plus 2. And I say, what's f of g of x? That's composition. Create a function that's composed of those two functions. What would that be? What would that look like? What are you putting into what? You're putting g into f. That's all you're doing. So what's that going to look like? So you're going to take this, shove it in there, right? So what's it going to look like? Square root x squared plus 2
Minus 1.
Yeah, and then you can simplify it. You got a semi with me? Semi. All right, so this problem is the other way around. It says, I'm going to give you what the function is at the end. You tell me what went into making it. So there's really an infinite number of possible answers, but they're all sort of related. So for example, if I said, here's h of x, and I said, okay, what goes into making this? There's several different ways to look at this. What's the most obvious kind of like, what looks like it's inside something else? I love it. Beautiful. One way to look at this. I get it. So the inside function, I'm going to call it g, just to kind of keep it consistent. She said the inside function looks like that. Well, what would it have been put into?
1 over x.
Yeah, just replace what I just called the inside with x. That's where, and then it would have been put in. So then f of x, if I put this here, I make that. Is that the only possible answer? Oh, hell no. Right? You could have said that g of x is square root of x. And then f of x would have been 1 over 2 minus x. Because if I put that there, I get this. Yeah. Right? Do you guys see that? This is going to be really important later this semester, this idea of inside function, outside function. It's huge, which is why I like that this problem is here. Yes?
Can you show it with 3? Because this one has...
Yeah, if you put another... Well, let's see. Let's take this guy then. Watch this guy. If I said, deconstruct this function using 3 other functions, right? Let's call this C for composition function, right? So then I want f of g of h. So I kind of always start with the innermost. So I could kind of do a combination of what I just did. I could say h of x is rad x. G of x would be the bottom 2 minus x. I mean, do you guys see what I'm saying? So if you can do 2, you should be able to break up one of those and make 3. You can just keep breaking it up. And there really is kind of an infinite number of answers. Because I could put arbitrary constants and have the other one cancel them out and stuff like that. I mean, that's kind of like all the same then. Hopefully you guys are semi with me. Because then what would the last thing be here?
1 over x.
So it's kind of like combining those two ideas. Plug that there, plug the result there, and I get this. Kick ass. Yeah, so the yield question, this question, those are two big ones I expect. There's certain things that if nobody asks me about, I'm like, well, nobody's doing the homework. Shit. So those are good, yes?
For number 1g, it's asking if the function is even odd or neither. And I know that we can figure it out from the way the function looks, or figure out from the formula or the equation of it. How do I get the equation out of it?
No, you don't want the equation. Screw the equation. You don't want the
I don't
equation.
have to worry
The
about
visual
it.
is much easier anyway. So there is a test for symmetry, odd or even, by putting negative x in and seeing what happens if you have the function. The visual is so much easier. Why do we call odd symmetry functions odd? One of the most basic reasons is odd powers look like odd, or have odd symmetry, right? So what does x cubed look like if I graph it? Can you guys do it in the air? One of my colleagues calls it, I give him shit about this. See if any of you guys have had this guy before. Somebody calls it a giraffe graph, because put a leg there, it looks like a giraffe. But I'm always like, so somebody cut his leg off, he's going to fall over. But, yeah, so I always take it there. I do. This is just fun. So yeah, no poor hobbly giraffe. This is cubish. Call it cubish. This is x cubed. If I would have drew it a little bit better, the idea of odd symmetry is that if positive x goes to a certain output, then negative x goes to the negative of that output. So 2 cubed is 8, negative 2 cubed is negative 8. So if you did have a function, you could plug it in to see, but if you don't have, you have the visual, is it symmetric through the origin? Is the mirror like through the origin? It's kind of a weird idea, but still, we can kind of see how that is. So obviously this function is, it's got odd symmetry, right? Even symmetry would be like x squared, where the positive x goes to the same thing as the negative x. Right, 2 squared is the same thing as negative 2 squared. Kick ass. Is that cool?
Can you go over the neither?
Well, neither would be just like, the easiest way to make it neither is just to move the parabola over.
Right.
See, it's still got symmetry, but its axis of symmetry is now moved. So it doesn't have officially even, because even and odd are relation to the y-axis and 0. So all I got to do is move it over, which seems kind of evil. And then we start talking about different axes of symmetry to say, oh yeah, the mirror just moved. What's the big deal? Yes?
I would recognize that if I saw it in a graph, but in like 17, when
Oh.
it's asking for all those, they're like I probably shouldn't.
Oh, I love
say
it.
the
Okay, so
answer.
what's the, so 17 is the one where you can actually apply the test. So the test is, if f of negative x equals f of x, what kind of symmetry is that? Even symmetry, because that means if I plug the negative number in, it's the same output, so that would be evenly symmetric. If f of negative x equals negative f of x, that's odd symmetry. And if neither of those is true, it's neither. So for example, what is the symmetry so far? Odd, because it's an odd number, right? And the minute I do this, now it's neither. Yeah, so that's one of the quickest ways to see for polynomials. If all the exponents are the same kind of number, so this is neither, whereas this is even symmetry. Now, if you look at the test, watch, if I put a negative x in, what happens? What's negative x to the fourth? X to the fourth. What's negative x squared? See how that's the same as it was? Right? And if they were odd powers, the negative would have stayed there. It would have been the opposite of what it was to begin with. So if the powers are the same type of number, odd or even, it's got that symmetry. If they're a mixture, nope. Now there might be, when you don't have, well, I mean, you know, you got to know trig functions, right? What kind of symmetry does sine have?
Well, isn't it even because it's, or no?
How does it go through 0? It's all about how it goes through 0. What's it do? Starts at 0, goes up this way, down that way. Odd symmetry. Now, that would be sine x. What does this do? That's what they're really asking about that problem, 1 plus sine x. What does that do? Careful, which way is it moved?
No, up.
Oh,
If it's in, now listen, this is awesome. x-axis, what does it govern? Which direction do things move if I change x? Left and right. So if it's in with the x, it moves left and right. If it ain't, it moves up and down. All the outputs that I used to get are now one bigger. So what happens visually? The whole thing shifts up. This, the whole thing would shift to the right one. 11. And real quick, if you ever had trouble with, it's a stupid minus, why is it right one? Because all my inputs have to be one bigger to overcome the minus one that I'm doing. That's why it's the opposite of what it said. Okay? And just to really hammer this home, can't I put this with the y? Opposite, so it would go up one on the y-axis. So if you put the number with the variable it can go with, you always interpret it the same way. The opposite of what I see. Isn't that kind of neat? Okay. So if I do apply this, everything goes up one, does it still have odd symmetry?
No.
No, it's not symmetric through the origin anymore. It's not symmetric. What's the thing with odd symmetry? Symmetric through the origin. The minute I screw with this point, it's doomed. Right? This thing, is it symmetric through the origin? No, it doesn't even exist down here. Right? Because of course the lowest sign is -1, so if I add 1, now the lowest is 0. It doesn't even go down there. You guys? Yes? Okay, I like it. So you guys are like, no idea. Okay, continue. Okay. Anything else? I think the other ones were all, even C is polynomial in nature because it's an x squared up there, right? And the exponent for the e. Okay. Anything else from that first? Yes?
When it asks for sketches of graphs, how much detail do you want?
All right, so I never, except for that yield problem, when they give you something that you can't possibly know the scale for, it's not even a function. But if they give you a function, I need to see some. If I said, sketch the graph of this, and you do this, what would it look like? And that's what you turn in? That's shit. That is complete shit. So the whole purpose of pre-calculus, when I teach pre-calculus, and when I say this, you're going to be like, thank God he didn't take you. But I tell them honestly, if I say this, you should agree with me. Pre-calculus is graphing hell. Is this a true statement? If you had a good teacher, yes. Because that's the whole purpose. You get to calculus, graphs should be quick and easy so that you can focus on the calculus. Pre-calculus gets you ready for that. Here, let's graph the shit out of everything. So in calculus, you're able to do quick sketches with a rough scale. So I do want to see some scale here. Right? And some points, yeah. Doesn't have to be super beautiful, but it does have to have some detail, not just thing. So for this it would be, you could just do some points, right? So 0 goes to 1, 1 goes to 0, -1 goes to 2, and then you can just plop the shape on top. Is that cool? Pre-calculus, end behavior. End behavior, right? Do you guys remember that? The end behavior of this guy is inverse cubish, is what I would call it, right? Normally cubes want to go like this. This guy wants to go like this. Because he's negative cube. Maybe. So the more you understand what the shape should be, the less points you should have to graph. But you still got to graph a few points. Yeah, don't give me what I put up here first. Here's the graph, Jeff. What the? No. Okay, all right. Anything else from chapter 1 stuff?
I won't overdo it, but number 16, I need a refresher on the...
Oh yeah, piecewise. Good. That's another one that's freaky. What's the whole idea with piecewise functions?
Separate.
Yeah.
They're separate on the graph.
It's kind of like if you had a missile go and then it gets hit by a meteorite. Another function takes over right at that instant, right? So you have one, the trajectory, and then bam, holy shit, and it has a different function that describes its motion now, right? So you have this instantaneous thing that happens to it. So this one says, looks like this for x less than 0. And it looks like e to the x minus 1. So what's the most kind of important point to look at? X equal to 0. That's the transition spot, right? On this side of things, it's easy as hell. What's it look like on this side? Yeah, line, slope, -1, going through the origin. What am I going to put right here? If I'm just looking at this, what am I going to put right here?
Open circle.
Yeah, open circle. Yep. Make that big, make it big. And now you just kind of pick up things with this guy. What's e to the 0? 1. Okay. Minus 1. So does it fill the hole in? Yes. Cool. And then you just keep going. You can do a couple more points. Doesn't have to be super perfect. Just, right? Put a 1 in, you're going to get...
I guess I was confused because I got the top two, but I left those open circle. And then, but I didn't know where to connect the center one. You have a -1, 1, and the 0. You know what I mean? The line.
Here?
Yeah, like I didn't realize
Well,
that it was a continuous
when
line.
is this rule in place? All the way up to just below 0, right? So it's in place for this x value. It's in place for this x value. So this is just going to keep going until it hits the place where it stops being this. Where does it stop being this? At 0. So whatever the pattern is, you're going to keep going until you hit the place where it stops being that. Does that grammar is a little weird, but
Because x is greater than or equal to 0 on
Yes.
the bottom line,
Yes.
wouldn't that origin be solid?
yes,
Is it equal to?
yeah. I just haven't started graphing this guy yet.
Oh.
But what did we just say? If you plug a 0 in for this guy, you do get, so it would fill this in. Now keep going.
Oh.
Put a few more points in. You know what e to the x looks like. What does e to the x look like? Yes. Okay, cool. So one person then. Whee. Right? So it goes like this, but I'm just going to be interested in this part. So you know what the shape is. You just got to get a couple points and then put the shape on top. So that's really what pre-calculus does. Shape, 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 shape. Specifics, details, but shape gets in your head. So now I just got to do a few points and put the shape on top. And yes, I am old school. I will let you use the calculator for some things, but most things will be by hand. Aww. Okay, just so you learn. Yeah? Kind of like my whole point of being here. Alright, I like it. Okay, anything else from there? Okay, so let's get back into chapter 2. I kind of don't like the order they do things in, and I'm going to come back to the specifics of section 2.1. I want to talk about 2.2.2.3 first, so just deal with that. It's too bad. We sort of started talking about a couple things. We talked about limits by themselves, and then we talked about 2.1, which we'll come back to, talks about trying to find the slope at a point. And we discussed last time about the logistics of that. What sucks about that is how many points do I need for slope? 2. So there seems to be an inherent problem there. So I don't like that they do this in section 2.1 before they even talk about the idea of limit, because they're using the idea before they tell you what the shit it is. Just to show you why I do things a little different order. Okay. Let's just focus on 2.2. So, we talked a little bit about limit. I somehow related it to a 1980s horror movie, The Blob, right? I don't know if you remember, if you were all here. What do I want to do first? Yeah, okay, let's do... No. Let's do it right here. I think we did this one yesterday. Did we do this one last time? So the most basic way, the most basic way to investigate a limit is to create a table. Because the whole thing about the blob thing was, if I'm not allowed to go to a certain place, I don't want to go where the little monster is exactly because of what the shit is going to do. So I'm going to get, but I'm like, what is this thing? I'm going to get really freaking close. So what? Obviously, I'm not allowed to go to 1. So the whole idea behind this is to investigate what happens at 1 by getting really close to 1. Because we kind of know what happens at 1. It's not really, but what happens at 1. You get that weird ass 0 over 0. And what's that called? Indeterminate. Which is kind of worse than undefined. Okay, I like it. So then we made a little table of values and investigated it. We did that last time. So let's do a fresh one. Let's see. What you got, Jeff? I don't know, Jeff. Let's do one we can, let's do this one. Let's do one we can do 2 different ways. Yeah, I like it. Let's do this. Kick ass. If you had to put together a table, and what people do, and this is not going to work, you have got to give yourself enough points on both sides so you can see a pattern. If you just jump straight to 4.0001, you're not going to have anything to see a pattern from. You guys understand what I'm saying? You've got to give yourself enough numbers from both sides to see a pattern. So what the shit am I talking about? So here, let me put in the middle, I'm going to put in parentheses 4, because that's the value I can't use. What happens at 4? 0 over 0. Okay, I like it. So I want to approach 4 from both sides. So what am I going to put coming from below? What would you say? Where should we start, maybe?
Do you want to go as far as 3, or do you want to go as close as
You tell me.
9?
So let's say 3. That's the 11th. So there's a suggestion. From 3, where would you want to go from there? Get closer. 3.5, sure. Get closer. 3.9, and then one more. 3.99. So then you can kind of mirror it on the other side, right? What would go here? 4.01, 4.1, 4.5, and 5. All right, you guys. So I'm approaching 4 from above, and I'm approaching 4 from below. Let me say that again. I'm approaching 4 from above. Do you guys see that? And I'm approaching 4 from below. When we go to the visual of this, what I just said is going to be remarkably important. It's important right now, but just really lay the groundwork. Do that. Fill that in. I'll do it with you so we all see if we agree on what we get. And maybe I'll show you a way to make this stupid expensive thing work for you. My battery's not low. Shut up. All right. You never turn off? Oh, I see. Bless you. So here's something that it'll be mildly useful, but it also kind of illustrates. Now don't worry, I'm going to zoom in a minute, but I'm letting you do some stuff. But it also illustrates a problem. So let me zoom in so you see what I'm doing. I don't know how much you guys know about what this little thing can do. All right, and of course you can't see shit. Let's see. There we go. Are you guys getting those numbers? Anybody? No? Yes?
Yes.
Some of you guys are like, let me just shake my head, yes. Anybody know how I did this ship? Yes? Cool. How did I do it?
Out of not having it on.
Good, good, good. So if you go to table set, second window to go to table set, you make independent variable ask. And if you do that, let me undo what I just did so you can see it create. Well, go away. I don't care. Let me see if that clears it. Yay, okay. So if you make table set, if you make independent variable ask, that means it's going to wait for you to tell it how to evaluate it. So normally when you go to table, you tell it where to start, and just kind of fills in the table automatically. Right. So I'm not sure if you guys have all seen this ask thing. So set it to ask, go to table, and now you can just plug in there 3, 3.5, 3.9, 3.99, 4.01, 4.1, 4.55. But do you see a bit of a problem here? Can anybody identify a problem? Oh, I forgot to put 4 in there, but this is going to be error, of course. And then so a couple things. You notice how it's changing a lot and then it's slowing down. It's changing a lot and then it's slowing down. So it seems to be... So if I had to make a guess based on what I see here, what would my guess be as far as the limit? What does it look like it's going towards at 4? So from above, it looks like it's going to what? 209 or 208 or something. From below, it looks like it's going to 208. So what would be somebody's guess for what it does right here?
0.2085.
Yeah, you would kind of like split the difference, right? But again, there's a problem here. There's a problem. This is really quick and nice, but how wide is this? Not very. It only lets 4 decimal places. There's a shit ton more decimals in there, right? So this is nice to kind of like fill in the, and then you want to come out of this and do specifically, you want to do specifically like 3.99. So we'll do, here's a really cool thing you can do. 3.99. You guys know about the store button? Watch this. Some of you guys do. 3.99, stow that away in X. And then I could just put the freaking X minus 4 divided by X cubed minus 64. Bam! So let's put a little more detail here. 0.0208855036. And then let's do 4.01. So watch how I can do 4.01. 4.01 store in X. Second enter, second enter. Bam. 0.0207813367. So what do you guys, what's your, do you have any recommendation about what the answer is or what I might need to do? Do you guys think we can see the answer now? What do you guys think? Did I get close enough? Let me just kind of give it away. Do you think I got close enough to 4? Maybe I should try to get a little closer. No? Do you guys start to see that? So I'd like to show you what you're going to actually be doing on these problems. You might have to step closer than you originally thought you did. Do you guys see how I can tell that? Can you really tell? You can still split the difference for a good guess. But let's make our guess a little bit better. Let's put in 3.999. And then let's put in 4.001. Oh, shit, half. There we go. So I get 208.385 and 208.281. I feel pretty good about the 208 piece, right? So 208. It looks like if you split the difference there, it's going to be 3, 3, roughly. That would be a good guess. That's a good guess. I also showed you how to get the exact answer. I don't know if anybody remembers. You're going to have to still do these tables. You're going to have to get used to using these tables. But what can I do to this to get the exact answer? I can't always do this, because it's not always going to be stuff I can factor like that. But I just kind of gave it away. So, of course, I put in there everybody's most hated factoring form. I really don't understand why, but understanding the idea here, what must be a piece of the bottom? That's a weird question to ask, and I don't care. What has to be a piece of the bottom? X minus 4, I'll bet you anything. So how do you get x cubed? What has to be there? X squared. How do you get minus 64? This has got to be... And what's the middle term going to be? Anybody remember? This is the Pulp Fiction cleanup dude. Plus, so you can kill the shit I don't want. 4x. So now what does this become? What happens? These kill each other. So what do I put here? No. 1 over. I like it. Can you figure out the answer now? Why was I not allowed to put a 4 in? Because it made 0 over 0. Why did it make 0 over 0? We now see because they both had an x minus 4 piece. I killed that piece. Can I put a 4 in now? When am I not allowed to divide these? When x is 4. Is x ever 4? What's the main idea of a limit? You never get to this number. That's why I'm allowed to do that shit. Now I can just plug a 4 in. Do you guys get the feel for this? If I can do an algebraic thing to this to simplify it, I might be able to remove the problem. Bam! Problem was I got 0 over 0. I don't know what the shit that is. Killed the problem. Now I know what the shit it is. What do you get when you plug a 4 in? 16 plus 16 plus 16. What is 1 divided by 48? Yeah? So our by hand guess was flipping good as all shit. You know, we're just human. What do you want from us? But that algebraic way gives me the exact answer, of course. You guys get the connection here a little bit? So the whole idea of a limit is there is a place, or one way to use a limit. I got to be careful, because the idea of limit's bigger. But one use for a limit is when there's a place I can't use directly. So I can kind of get close to it to see what it looks like it's going to do. If I had a graph of this, what would go at the point x equals 4? What would be there? At 0.02083333. What would be there on the graph? If I graph this, what's going to happen at 4? What's going to be there?
Open circle.
Open circle. Now I know where that open circle should be. It should be at this output. Do you see the connection? Yes. Maybe. So real quick, so I have it in here already, so I can use the table. If I graph it, of course, I have statistical shit in here. Let me get that out of here. Don't worry about this stuff. I don't want statistics. Go away, stop it. Just look at it directly, Jeff. There you go, buddy. So now if I graph this thing, of course it's really tiny. Look, it's really close to the x-axis. Let me blow this up a little bit for us. You guys should be familiar, hopefully, with what I just did with the window. There we go. Look at the little dude. So now if I try to ask it second calc value and I put a 4 in there, there's an open circle, right? Do you see it? Because this is y equals empty. Not even 0, just you've fallen off the reality. You went into a crack in the universe. It's crazy. An open circle. Okay, I like it. You guys? Okay, I like it. Would you say then, just to kind of get ahead of ourselves a little bit, would you say that this is a continuous? Just that word continuous. We haven't even officially talked about it, but what if it is continuous, what should I be able to do? I should be able to just go, like I imagine a little car driving. Can that car successfully travel all along this function? What's going to happen at this point is going to fall into that sinkhole, right? I like it. I just rewatched This Is the End with Seth Rogen all in a sinkhole. Demons and shit, so you don't want to do that. All right. So there's a couple different ideas. There's this idea, which is from 2.2, and then there's the algebraic way, which is really from 2.3. I like it. I like it. There's one more idea I want to talk about, and then I can give you this little worksheet to work on. It's that idea, I want to expand on this idea of from both sides. So here, let me see. Has everybody got this here stuff? Okay. I should probably get the camera back around. Hire a camera person to help me out. Look at me being all PC. Okay. If I did, can somebody do this without even a table? What happens when you divide by smaller and smaller numbers? You get what kind of outputs? Because isn't that what's happening here? I'm letting x go to 0. What does this really mean, this notation? What's it really mean? I'll take a couple things. What's that notation really mean? Can't get to 0. X is never equal to 0. But it does mean I approach 0 from both sides. So there will be notation if I only want to approach from one side. I like it. So if I don't see anything extra on top of this shit, that means go to 0 from both sides. What happens if I go to 0 from above? It looks like we might have to do this. If I put a 0.1 in, what is 1 divided by 0.1? Yeah, because 0.1 is 1/10. So it's really just reciprocate. This is just the reciprocate function. Do you guys see that? Just reciprocate whatever x is. So if I put 0.01 in, that's 100. 0.001, that's... So if I just do it from the one side, what's it look like this is going to? Infinity. But I haven't done due diligence. I never use that phrase, but oh, there it is. I have to approach it from the other side. What about negative 0.1, negative 0.01, negative 0.001? That's also going to 0, right? So the outputs would be negative 10, negative 100, negative 1,000. Somebody should know what this thing looks like. What does this thing look like? It's the most basic hyperbola. Xiao and Shuang. I should have worn my little shirt today with Gandalf at the... There's an asymptote. He's like, you shall not pass. I wore that in the day of the final. That was maybe not the best time. So the people that take it personally, maybe you should. So look what happens. Is there a limit at 0? If it was this, what would the limit be? Positive infinity. Which is another way of saying no limit, but it's a specific kind of no limit. It goes, they agree on positive infinity. But it's this. From this side, it looks like it's going up forever. From this side, it looks like it's going down forever. So what is it doing right at 0? I can't say. What is the limit at 0? Does not exist. Because they don't agree. So the other tables we did earlier, they agreed. It looked like they were going for a certain number from both sides. If they don't agree, there can't be a limit. So I want to transition to a more visual approach to this idea. What do I mean by that? I mean, here's the easiest way to kind of show that without using infinities. If I have something like, let's say this is 3, why not? Say this is 4, we'll say this is negative 2. All right. This graph sucks, but it's good enough right now. All right? Because obviously you got the most important parts there. Does a limit exist at 3? Why? They don't agree, right? It's like my friend goes here, gets on the phone, says, "Where are you at?" And I'm like, "I'm almost up here." And we don't agree on where we're supposed to be, right? It's a very simple way. So officially, the limit as x goes to 3 of this function does not exist. But let me ask you some more specific questions, and don't let this be harder. It's as easy as it seems. You got to let it be easy. What is the limit as x goes to 3 from below? If I put a little negative sign up here, and people, not below like your jaws, but below in terms of x, right? From the left. So as you approach 3 from the left, what is the function doing? So as I approach 3, what's the function doing? It looks like it's going to 4. I love it. Do you guys see that? Don't look up and no. From the left, from below, from the left. So what's that? That's going to be, it looks like it's 4. And what's the limit as x goes to 3 from the right? Looks like it's going to -2. Can you guys see that? It's nothing more than that. From below means from the left. What's the outputs doing as x gets close to that number? The outputs are going to 4. What are the outputs doing as you go from above, from the right? The outputs are going towards 2, -2. And then you can see they don't agree. That's why this does not exist. They don't agree. Okay. So, this is sort of this has got everything we've talked about so far in terms of limits. If you would like, you can work together. If you don't trust other people, you don't have to. You can try it and bounce answers off of other people near you. Right? We're going to go over this together.